welcome to 1.3. In this video we are going to learn how to do some basic calculations with our significant figures. So this is called Math with Measurements. Our learning goals today are to convert between scientific notation and standard notation. Again, that's probably something that you've already learned before. We're going to learn how to do some math calculations with significant figures, and then we're also going to learn how to round our answers to the correct number of significant figures. So the first thing that we're going to be addressing today is the conversion between scientific notation and standard notation. So what I want to show you here is scientific notation numbers are written like this. This is an example of a scientific notation number. It's when you have a number that has one number in front of the decimal, and then you have this guy after it. It's a times 10 to a certain power. So what does this mean? What does this part mean? Well, if you have the number 1, then you could say that it's times 10 to the 0 power, meaning that it's not times 10 at all. It's times 0 tens, okay? But if we have the number 10, it's like we took 1, okay, and we added 1 10 to it. So here we have 100. You can see there's 2 zeros here, so it's multiplied by 10 twice. This has 3 zeros, so it's multiplied by 10 3 times. And then this has 4 zeros, multiplied by 10 4 times. So why do we use this? Well, if I have a number like this, 64,000, that's a big number. Well, let's do it like this. That's a big number, and it would just be annoying to write the whole number. So instead of writing the whole number, I take my decimal, which is right here, and I move it all the way till there's only one number to the left of it. So I move it 1, 2, 3, 4, 5, 6, 7 places. Put the dot right here. So I rewrite it as 6.4, and I just moved it 7 places. So that means I'm going to put times 10, and I'm going to put a 7 here. Okay, that means this number 6.4. If we are going to convert it back, we're going to have to multiply it by 7 tens. Okay. Same thing can occur when you have a negative. I don't know if you guys have ever been exposed to a number with a negative exponent, but that means that the decimal is going to be moved in a direction that makes the number smaller. Okay, so if I have a number that looks like this, so 5.2 times 10 to the third, what does that mean? That means that it's now a smaller number. So think negative means a smaller number, positive means a bigger number. So to make this a smaller number, I'm going to move my decimal 3 places to the left because I want to make a smaller number. So here's 5, 2. The decimal was here, so 1, 2, 3. I moved it 3 spots. And so this is the new value. Okay. So let's do some practice problems here. Unfortunately, these give me all the answers. Whoops. These I was supposed to give the value, and then I was supposed to convert it. This is called standard notation. That's the normal number, and we're supposed to convert to scientific. So how do we do that? Well, we take the decimal and we want to move it till there's only one number to the left. So I would count how many spaces I'd move it. And when I counted this, it would be 8 spaces. So I rewrote it as 9.02 times 10 to the 8th, okay? Let's look at one of these. Here's the decimal. I want to make it to where there's only one number to the left of the decimal. So I want to move it right here, okay, where there's just one number, the 8, to the left of it. So move it 1, 2, 3, 4 places, but it's a small number, so I have to put the negative, meaning the 8.82, I have to make it smaller to get to the actual answer here. Okay. So now let's do scientific into standard. This one I think is easier. This positive 5 means I add 5 spaces. So the decimal was here. So 1, 2, 3, 4, 5. Now I put the decimal here. So it's 502,000. Okay, let's do this one. It's a negative 6, so I move the decimal this other direction to make it a smaller number. It was 4.90, but now I'm going to move it 6 spaces. So 1, 2, 3, 4, 5, 6. I put my decimal and I fill each of these spots with a 0. Okay, so it's 0.000000490. Okay, and then these are just more practice problems. Now what I want to do is to review the rules of significant figures and then to figure out how we do rounding. All right, let's review the basic rules for significant digits. All the digits in a measurement are significant except for zeros that are placeholders, right? So 35 has 2 significant figures or digits. 35.0 has 3. And so you might say, well, why is this 0 counting? Well, it's not a placeholder, right? I added it on purpose. Another way we could say it is zeros at the end count if a decimal is present, which it is. And then this 0 counts as significant, making this number having 4 significant digits because it's in between 2 numbers, right? It's actually was measured. If the 5 was measured and the 8 was estimated, that means the 0 must have been measured as well. Okay, here's an example. We have 0.053 has 2 significant digits because these zeros right here are placeholders, okay? The leading zeros or zeros in front are never ever significant. So how many digits, significant digits, are in this value right here? Well, we know the beginning zeros right here are never significant, so these 3 do not count. The middle 0 counts because it's in between measured numbers, and then the 0 at the very end does not count, does count because it was added on specifically because it was the estimated digit. Another way we could say that is zeros at the end count if a decimal is present somewhere. So we would say 1, 2, 3, 4. So we have 4 digits. So correct, only the leading zeros are not significant. Now what I want to do is go back to, sorry, I'm going to skip through some of these here. Now I want to go to rounding. In just a minute, we are going to talk about how to round, or really why we need to round our numbers. But for right now, we're just going to learn how to round, okay? So let's say that this is our answer after we've done a calculation, and I don't know if you've seen this in a calculator, but sometimes it gives you a really long number, and you're like, I don't want to write all that down. Well, maybe your teacher says, I only want you to have 3 significant digits in your answer. So what does that mean? Well, that means that the 9, the 4, and the 5 are the first 3 significant digits, and so those are the ones we want to keep, and we are going to get rid of the ones on the end, okay? So let's learn the rules for how we do that. So, okay, I get what it's saying. So if the first non-significant digit is less than 5, you'll drop all the non-significant digits. Okay, so that might have just sounded super confusing, which it kind of did for me the first time. So what I recommend doing is count out your 3 significant digits, okay? So let's say we're supposed to have 3. So here's 1, here's 2, here's 3. All the rest of these are not significant. I mean, they really are significant numbers, but we don't want them, right? We want to get rid of them. We only want 3. 1, 2, 3. So what are we going to do? Always keep your first, like 1 or 2, you know. The very last one, though, we need to determine if it's going to stay this number or if it's going to round up. Okay, so the only way we know how to do that is to look at the one right next to it. So this is what's called the first non-significant digit. That 3 is non-significant because we don't want it, right? We're going to only round to 3 numbers. Well, that's the 4th number, so we need to get rid of that guy. So it's a 3. If it's less than 5, then you can just get rid of it, and your answer is 9.45. If it's 5 or higher, that means that I'm going to need to round my last significant digit up 1. Okay, so if the 3 was in fact like an 8 or something, then I would round this to 9.46. So let's do some practice problems. Okay, this number right here, we want to round to 3 significant digits. So do we make it 0.0594 or 0.059? Well, if we want 3 significant digits, let's count. This is 1, this is 2, this is 3. So 594 are our 3 significant digits. We have to check the one next to it though, the 2. We have to make sure it's less than 5. 2 is less than 5, so I can cross out the rest of these. Okay, we cannot use them. So my answer is 0.0594. Okay, let's do another problem. Let's round this really big number to 2 significant digits. Okay, well let's count. Here's significant digit number 1. Here's significant digit number 2. So what about the 9? Well, the 9 is greater than 5, so it means I need to round this 7 up to an 8, right? So it's 48. Now you might think, is 48 the answer? Well, no, 48 can't be the answer because why is it deleting it? That's really annoying. Okay, 48 can't be the answer. Why is that? Because 47,000 does not round to 48, okay? We could round 47,000 to 48,000, right? Well, then you might be asking, well, Mrs. Millsap, last time you just got rid of these numbers. Well, the reason I could have just chopped them off is because they were, to the right of the decimal. But now I need to instead fill them with placeholders so that this number maintains its same basic value. So you can put in placeholder zeros. Remember that placeholder zeros are not significant, so I still only have 2 significant. Okay, so why do we have to round our answers? Why can't we just leave them nice and long? Well, there are some rules when we're add and we subtract our measurements that we have to follow with significant figures. Okay, when we add or subtract measurements, the answer is limited by the value with the most uncertainty or the more uncertain answer. Okay, let's say I have a value, I measured something that was 6 grams and I measured something that was 2.00 grams and I want to add them together. Well, you might think it's 8.00 grams, right, if you're adding them together. But that's not how it works. You have to count how many, what's the level of precision of this answer? Well, this answer right here is in the ones place, right? And this answer goes all the way to the hundredths place. So whenever we're adding or subtracting, we always need to round our answer to be the same as the number that was the least precise. So the 6 is precise to the ones, whereas the 2.00 was precise to the hundredths. So our answer can only be precise to the ones place. So that means my answer can't be 8.00. I have to round it so that I just have the 8 grams. Okay, let's practice another problem. We have these 3 numbers. What's the answer? Well, we have to ask ourselves, what's the precision of each of these answers? Well, this one goes to the tenths, right? Goes all the way to the tenths place. This answer goes only to the ones, and this goes to the hundredths place. What does our answer going to be? Well, the first thing I do is I just add everything together like normal. Okay, I added everything down on my columns just like I normally do, a regular addition problem. Okay, so I get 120.00, but I have to round it. Okay, am I going to round it to the hundredths? No. The tenths? No. I'm going to round it to the ones, the least precise, which means my last number has to be in the ones place. So I'm going to do 120, and I'm going to put a decimal here so that you know my 0 is not just a placeholder, okay? That 1 is an actual value. The ones place has an actual value. Okay, let's do one more addition, one more subtraction. So I have 23.9 grams minus 1.15 grams, and the answer is 22.75 grams. Now, I have to round it correctly, right? So I ask myself, the first number, what is its precision? Well, it goes to the tenths. This one goes to the hundredths. So I have to round my answer to the least precision, which is the tenths. So I can only have a number here, which means I've got to round this guy off. So I'm going to round it up to 8 and get rid of the 5 here, okay? So 22.8 would be my answer. Okay, multiplying and dividing actually has a different set of rules, and I think they're a little bit easier. When multiplying or dividing, we don't care about the actual level of precision. All we care about is the number of significant figures, and we'll always round to the least number of significant figures. Okay, we round to the least number of significant figures. So our first problem, we have 3.0 times 252.00. How many significant figures are in this first number? You should say 2. The 0 counts because it's at the end and there's a decimal. How many significant figures are in this second number? You should have said 5. These 2 zeros at the end count because there's a decimal. So we always round to the smallest number, which means whatever we get for our answer in the calculator, we need to round it to 2. Okay, so when I plug this in my calculator, I get 756 in my calculator. But I can only have 2 significant numbers. Right now I have 1, 2, 3. That's not okay. So I have to round this to 2. So this is going to be 1, this is going to be 1, this has to be rounded off. And so we have to make this a placeholder. We have to make it a 0, right? So since this is a 6, it's greater than 5, I'm going to round this guy up. So 760 will be my answer. Okay, later on in the next video, we are going to do problems like this. This is called dimensional analysis, and we'll learn more about that later. All you need to know now is that we have a bunch of multiplying and division problems all in one, right? So you might think to yourself, what am I supposed to do? Well, we do the same thing that we did before. We count the significant figures in every single number, okay? How many significant figures are in this first number? You should say 2, because these zeros in front never ever count as significant. So it's 2 significant figures. These other 4 should be pretty easy, that they all have 3 significant figures, right? So we always round to the least number. So that means our answer can only have 2 significant figures, okay? So when I plug this into my calculator, you are going to get 0.0948. Now, is that your answer? No, because we can only have 2 significant figures. So I can have the 9 and I can have the 4, but I can't have the 8. This has to go. But since the 8 is greater than 5, I can round up the 4 to a 5. So it's 0.095. And that is it for our video on how to round our answers when we're multiplying, dividing, adding, and subtracting.